without much more ado, I'll hand over to Phil, and then we've got two other talks this morning.
Hi, good to see everybody. Yeah, so as David said, yesterday we were looking at the big challenges and cross-cutting. Today we're looking much more in a much more focused way on the research areas. What I want to do over the next 10 minutes really is just quickly walk through, for some of you perhaps not so familiar with our approach and our framework, so you get a good feel for that. But I would echo exactly the point that David made, which is that it's all very well having facilities, but really what we're trying to do is to support communities. And we can only do that by engagement. So please don't regard your visit to the Royce as a visitor, regard your visit to the Royce as part of the Royce. It's really, really important we go over the idea that the Royce is much more than just those core partner organisations. It's about supporting the UK and helping us to achieve global competitiveness in advanced materials. So if I start, I just want to, I took this from the job description actually of our research area leads. I know we have a number of research area leads in the meeting, and their aim is to develop groups that will help to provide strategic leadership within the Royce and across the research areas, and to support their wider development, not just within the Royce, but nationally, taking advantages of all the strengths we have across universities, research technology organisations, and industry. And one of their remits is to develop working groups and to bring people together. So if you have ideas, please go and talk to the research area leads. I can see Edmund, I can see Richard over there in Atoms to Devices. As we go through, I will point people out as we go through the various ones. But if you have ideas, don't sit there saying, oh, why on earth doesn't the advanced metallics processing area, why on earth haven't they had a meeting to look at novel illuminates? In the processing of illuminates. If you think that's something we should be doing, then it is up to you to go and speak to them and say, look, I'd really like us to run a meeting in that way. It's very, very important we get over this idea that Royce is not top down, it's bottom up. So please, if you have thoughts about ways to contribute, please contribute. So I just want to give you a very quick overview, and this is a map that kind of shows how it works. So we have a number of research areas. You'll notice that there are two, those of you who've seen this picture before will know there are two new areas, which is imaging and characterization and modeling and simulation. And that's because when we set up, we were given the remit of setting up research infrastructures, going out and bringing in kit. And I was very keen at that time that we didn't just all do the same thing, that we focused on particular areas and left some areas that we may not be able to support fully. So, the advanced metals processing, atoms to devices, biomedical materials, and so on were areas that we have focused our facilities and investments. But clearly, and I remember Peter Haynes at Imperial used to say, well, where's modelling and characterisation? And we said, well, it's clearly critical to all of these areas. And where's imaging and characterisation? Well, we could easily have gone off and spent all our money on electron microscopes. I'm sure Sarah, I can see in the audience, would say that would be a great way to spend all our money. But we need to be driven by outputs. And so we really needed to ask the question, what kind of imaging and characterisation do we need? What will support the electrochemical systems activity? What do we need to support advanced metals processing, etc.? So that's why we didn't have those groups at the beginning, because we didn't want to go off and just buy the latest microscope or the latest X-ray CT system. We wanted our purchases in those areas to be focused in areas that would support these research areas. And of course, a microscope, for example, is not going to just support one area, it's going to support a number of areas. So what we have underneath those research areas is the national research facilities. So some of them are EPSRC national research facilities, such as NXCT, which has a stall outside, and our XPS facilities, which are part of Harwell XPS. But some of them are just facilities that we are making available, and a number of the facility leaders are here in the audience as well. And so, those are things you can access and take advantage of. I'm going to take us on a very, very quick journey through the different research areas. As I said, there are lots of research areas that are missing from this list. This reflects the strengths of the original partners and where they felt they could make the biggest impact. So if we look at two-dimensional materials is largely focused around our activities here in Manchester at the National Graphene Institute and in Cambridge. And really the aim is to be able to make and characterize novel 2D structures, whether those are 2D structures that go into composites, whether they're 2D structures that go into the electrodes within batteries, or whether they're exciting twistronics type materials where you control the layer or misorientations from layer to layer. So world-class facilities, and I think we've done some really, really exciting work there. And two of our younger members have gone on to receive Blavatnik Awards, for example, in this area. The second one is advanced metals processing, and that is led out of Sheffield with very strong involvement in Manchester, but again, some key academics in other universities have played a really big role in this. A large focus on additive manufacturing and powder processing at Sheffield, and a focus primarily on thermomechanical processing in Manchester. Again, if you would like to see any facilities, I think is Ed still in the room? Ed Pickering in the room? He was here last night, maybe he's not here, but Corin is in the room, and Richard, we've got people in the room here. So if you would like to know more about the Sheffield group, they're easy to find because they're wearing black Sheffield Royce polo shirts. And if you want to see the Manchester facilities, I don't know if Ross is here, but if you want to see those, please come and speak to me. Ed's just had a baby, so he may have had a late night, I don't know. Or may have had a late night, because I left him at the dinner last night, maybe he had a late night at the dinner. Atoms to Devices is led out of Leeds, Imperial, Cambridge, and Manchester, and there's a lot of exciting things there in terms of making structures by laying them down, and also a big input into quantum. So how do we make materials for quantum? And as we said, Richard and Edmund are there, and Manish is somewhere in the audience as well. There we are. If you'd like to play a role in that, please let them know. There was a big conference here 6 months ago, an international conference. In biomedical materials, our activity is largely focused in Manchester, but we also have activities in Sheffield, and we have exciting bioelectronic activities now that are starting in Imperial College and at Cambridge. So really exciting opportunities to make biomedical materials and biomedical devices. Our chemical materials design started and was founded really upon what we have at Liverpool, at the Materials Innovation Factory there, the ability to be able to make, which fits really well with the Materials 4.0 discussion we had yesterday, the ability to be able to formulate materials, small batches of materials using robotic processing. So this shows our formulation engine, which allows you to make a whole series of different formulations, but this is an area that really is, that Liverpool is providing a national lead. And if you haven't read it, there's a really wonderful article called The Robotic Chemist, where a robot runs for a week making a whole series of formulations. But the link between that and our ability to develop models and to develop use machine learning to invent the next generation of materials is really, really exciting. But that's been complemented by the sustainable hub in Manchester. Mike Shaver gave a talk yesterday. And he's just been appointed to a Royal Academy of Engineering chair working with Polestar to develop polymers, sustainable polymers for the automotive industry to complement the work he's already been doing in packaging. But again, if you're interested in that please speak to us. We also have activity at Oxford now with Charlotte Williams, who's just part of the Economiser bid, and we have the ability to look at recycled materials there, and then the ability to make materials using synthetic biology through the MIB here in Manchester. So really exciting, if you like, the chemical make aspect is covered through this theme. Electrochemical Systems was founded around our activity in batteries, and we launched the battery centre at Oxford about 6 months ago. And obviously Sir Peter Bruce has made a massive impact there, but lots and lots of new appointments, including Rob. Is Rob Weatherup in the audience? There's Rob. So again, if you're interested in that, talk to Rob or talk to Robin Morris. He was here yesterday. Is Robin here? They certainly people to speak to, but we've also recently invested in electrolyzers and the ability to generate hydrogen. So it's not just about lithium batteries; it's about batteries as a whole, but it's also about electrolyzers. There's also some really exciting work in Sheffield, and I think there've just been 4 or 5. I don't know, Rob, is that right? There've been 4 or 5 large projects just announced, isn't that right? Through the Faraday, yeah.
Sorry, four big Faraday projects for use, yeah.
Yeah, so again, really significant investments. If you're interested in that and getting involved in that, please speak to Rob. Material Systems for Demanding Environments is led by Brian Connolly. Brian, you in the room somewhere? Yeah, there we are at the middle. And again, with really strong collaborations with Cranfield University, looking at a whole range of materials, whether that's aero engine, whether that's in nuclear environments, whether that's in complex chemical environments. So really fantastic suite of facilities. In the nuclear materials area, we have collaborations with AA Technology, NNL, and Manchester primarily, but also very strong links with a number of other projects at Bristol and Sheffield and Oxford and elsewhere. And so there's a really strong community of people working together to develop tomorrow's nuclear materials and to better understand the materials of today. The image shows the materials testing research labs at AA Technology, where you can study materials, but we can look at materials at all levels of radiation, from very high alpha and beta right through to small TM samples. So we have a very good integrated capability across NNL and AA Technology in the universities to do some really exciting work there. And as I said, modelling and simulation is one of the 2 new areas. Chris Race, is Chris in the room? Yeah, Chris is there. Oh, there's Neil at the back as well. Good to see Neil, Atoms to Devices, Imperial College. Chris is bringing together a group in the modelling and simulation area. We had a very good session yesterday on Materials 4.0. If you're interested in contributing to that, please speak to Chris. I think it's a really exciting area, and obviously it includes things like AI, data and digital twinning. It involves key links with people like MPL. I don't know if Andrew or Steph are still here. Yeah, Andrew, yeah, Steph, there we are. So MPL is really important in terms of the veracity of data, understanding measurements and so forth. So some really exciting collaborations there. And then imaging and characterization. I mean, we have some amazing facilities. I call it a cathedral to electron microscopy down in the basement of MECD, and we have X-ray imaging over in the building next door. It's probably that way, is it? No, it's that way. It's that way. In the building that way. If you're really interested and you want to have a look at some of those facilities, please talk to Sarah or myself, and we can arrange that either now or another time. But there are some really exciting facilities elsewhere. Everything from an atom probe at Oxford through to the XPS facilities at Leeds, through to battery characterization at Oxford, through to the ability to do a whole range of chemical analyses, both up on the 6th floor at the Royce, if you're looking at polymers, or a whole range of other spectroscopies at the Materials Innovation Factory in Liverpool. So really, you have a fantastic palette of facilities that you can have access to, and all you need to do is contact us, and we will help you to get access to those machines and capability. And please put them on research grants. If you're thinking of using a facility and you want to just put it on a research grant, we can give you the costs for doing so, and then you'll be guaranteed access if you get that grant to use those facilities. Okay, I think that was really all I wanted to say. I'm really looking forward to today. Today is very much about hearing from the community where your ambitions are, what your priorities are, what your complaints are about our support of these particular materials research areas, and I think it's going to be very exciting.
Has anyone got any questions they want to ask Phil?
I'm wondering what the connection with industry is as well, because obviously this is fantastic for academics, but what's your relationship with industry and allowing academic industry collaboration with your facilities?
Yeah, that's a really important and good question. There's a number of different ways that you can interact with us. We have the industrial collaboration program that we run annually, which will support projects between industry and universities, so that will fund access to facilities. We also have, if anyone would just like to come and use our facilities, you can come and talk to us. We can tell you what it would cost per day, and you can either come and get involved in those experiments. So, for example, you wanted to do some additive manufacturing, you could go to Sheffield, they would give you support in doing those experiments. Or if you wanted to come to Manchester, say, to do some X-ray imaging, we can do that either, as I say, remote. You can stay remote and just send us the samples, or you can come and use the facilities, so you can do that. Yes.
Both academia and industry, where you can learn a lot more about the technique themselves by interacting with the technicians.
I should have set you to ask these questions beforehand. Absolutely. We do run a lot of workshops. So, for example, we ran a workshop with Zeiss recently looking at super resolution imaging. So we do run workshops on techniques. We run workshops, for example, on the use of 3D imaging packages to understand the data you've just collected, for example. And we run courses on electron microscopy methods. So we do run those regularly. We've just run a course on clean room activity. I think Edmund ran a course at Leeds on use of clean rooms and how to do that. Those are open to industry as well as to academics. If there are particular things you would really like to know, if it's you really as a company think it would be great to know more about the opportunities for, let's say, rapid formulation of materials, then we can talk to University of Liverpool and say, would you be able to run a short course, and we can advertise it. So we can do that kind of thing. So yeah, we kind of guess what people need, and we do get quite good attendance at some of our meetings. But if somebody has an idea, it would be really fantastic if we ran an industry academic workshop on X, or the training on nano-indentation, for example, then please speak to us.
Yeah, so just to add, Tom, I don't know if Tom Hancock's in the...
Tom was.
Oh yeah, there he is, waving his arm over in the corner. So Tom is gradually expanding, actually, we're rapidly expanding a whole road of technical programs. A lot of those are around awareness, actually, about what these capabilities can do, as well as that hands-on activity. And just to follow up on the industrial side, for SMEs, we do have an access scheme. So particularly if they're doing exploratory work, so there's that we will fund that and support that access.
Co-fund it.
As we move forward, we have to think about state aid, but for SMEs, actually getting that first rung on and losing and seeing if it's going to work for them, yes, that's something we do very easily. And we really want to encourage that, so it's a really important question.